Okay, welcome to the room. Welcome to the next talk. We have my colleague Rohit introducing next-gen virtual routers and zero-downtime upgrades. Please give it up for Rohit.
Thank you all. What a privilege to be here. But don't give up on me yet. I've got a talk to do. So, well, that's one of the jokes on router I got from the, internet. I know that's not funny. Yeah, it will be a sin to not use the puns here, but you see where this is going. Some of the folks joining online in the conference here in the sort of hall here know this is not my first virtual router talk. So, yeah, that's what you sort of thought, right? I'll be done. No. Why? Because this is a slide from one of my ex-colleagues, Abhinandan. Back in, I think, 2017, we scanned through all the service tickets we sort of got, and virtual routers seems to be a pain point for a whole lot of people, right? That's why there's so much work to be done in virtual router that we have done so far, and I hope we will be eventually able to, solve all those pain points. So this is episode 4 in the series. And the 3 of the talks I've given in the past, they kind of have a pattern, but what I'm happy to share with the viewers online and the audience here is we're making a whole lot of progress, and this is what the talk is about: the next-gen virtual router and the zero-downtime upgrades. I'm Rohit Yadav. I lead the engineering function at ShapeBlue, and I've been in the community for over 10 years now. And a little bit about ShapeBlue. We are an employee-owned company now, and we are hiring. So just in case the folks out there, we have an interesting thing to discuss, you can reach out to me or Charles. In this talk, we'll look at the history and some of the changes we've done over the course of last 1 to 2 years. Specifically, we'll talk about the systemvmtemplate changes. There's a new feature called live patching we've introduced. I'll talk about that. And zero-downtime upgrade is really a side effect of those features available to users and operators, service providers. So now you can plan your upgrades in a way where you can achieve zero-downtime upgrades. And of course, we'll go through a demo and we'll have time for Q&A. Just to kind of, in retrospect, look at what it used to be like to have system VMs sort of created and patched. So this is the usual workflow, right? You'll start with a system template. CloudStack will send a command line string, and you had something called the systemvm.iso file, which essentially contained the router or the SSVM, CPVM software, which is in the agent.zip file, and then using a sequence of events, you'll mount the systemvm.iso, you'll pass the command line, you'll start the VM, and if everything goes well, CloudStack will create the system VM into one of the virtual routers, SSVM and CPVM and whatnot. And one of the issues with, let's say, this model was for every hypervisor, you had a different style or approach or way to patch the system. For KVM and, let's say, Zen server, you'll need the systemvm.iso on the host, the hypervisor host. In case of VMware, we'll put it on the secondary storage. Now we're trying to improve and experiment with some changes here where we tested, what would it take to replace systemvm.iso? The payload size, at least for virtual router, the payload size is a tarball script, which is a couple of hundreds of KBs in size. So couldn't like systemvmtemplate be patched by doing like an SSH or HCP, which is more secure? It removes dependency on the secondary storage, and it removes the sort of use of this custom systemvm.iso. So we did a couple of tests in our labs, scalability tests, upgrade tests, and we found practically there's no difference in terms of speed and the effective amount of time it takes to patch and create the system VM. So we said, let's just experiment with SSH and HCP to pass this software payload, right? So when the system template starts, we still pass the command line, but now patching happens through this SSH-based mechanism, so where management server can go directly patch the system VM. And in order to do that, we had to split the initialization of various systemd services inside the systemvm template. So we have the cloud pre-init service, of course, which then consumes the command line, and then it will set up SSH server, and then management server will wait. If it is able to SSH, then it will copy the payload, and then rest of the scripts like the cloud early config and post init will bootstrap. And that's just the mechanism of what's before and after. The other big change we've done starting CloudStack 4.16 is historically the systemvm template is a separate thing which is hosted somewhere. So must have seen the quick install guide or the release notes or the upgrade notes where it will say something like go and register this template prior to an upgrade. And when you have a complex environment, multiple zones, multiple secondary storage, it can create a whole lot of error points where somebody will not read the release notes or miss out on a detail, and they end up with let's say, an inconvenient upgrade, and that causes a lot of pain point. So we thought the systemvm template is part of the product. It's part of the release. Why can't we just bundle it in the RPM and dev files so that when somebody wants to install or upgrade CloudStack, they don't have to read the release notes? And we just did that. We automated the life cycle of installing and setting up the systemvm template in a fresh environment, but also upgrading it as part of an upgrade. So upgrades are so simple. Now you can do an apt upgrade on, let's say, Ubuntu-based management server host, or you can use YUM or DNF. And I wonder if other stacks in the ecosystem, our competitors in the open space or open source space can claim, just do that and it will upgrade your cloud environment. So we've started with 4.16 and we tuned it. And I think in 4.17, this just works, much like CloudStack. The other thing is systemvm.iso is history, so we don't have that. And as a consequence of this, software upgrade and patching is more secure, happens on SSH and HCP. In some environments, like for VMware, you put the systemvm.iso on a secondary storage, which can be even a security issue in how you've kind of configured your environment. The other thing we've noticed is equivalent or sometimes faster than using the old approach. The other outcomes we observe is when you start or restart management service, the management server doesn't wait for the inject keys.sh script. So your management server effectively starts faster. And of course, there's no dependency on secondary storage. So this is sort of a high-level overview of what the system VM and virtual router lifecycle looks like. So we start by building it using Packer, and we would host it somewhere. Previously, now we package it in the deb and RPM packages that we build and produce. And it's all configurable. So if somebody doesn't want that, there are Maven build flags you can pass, and you can create your own custom packages to include or not include the system templates or include for specific hypervisors. We've automated the lifecycle to install, upgrade, set up, configure the system templates, which makes one less thing to sort of worry about. In terms of lifecycle, we have deprecated and removed systemvm.iso. Now, one of the things with systemvm.iso is it essentially contains the software for your router, the software for your SSVM and CPVM, which only gets configured and installed when you create them. What happens when you make changes to that or when you upgrade CloudStack? So we introduce a new set of APIs. We call them live patching, which essentially kicks in the same life cycle. So when your VR is running, you can upgrade the software on the fly, and that essentially what resolves and creates downtime upgrades for users. So that's what we will talk about, live patching. It's supported from CloudStack 4.17 and onwards, and it's backward compatible with certain versions and with certain caveats that I'll talk about. Operators, admins, users can now use live patching to upgrade routers using this mechanism without network downtime, the data path downtime for their guest VMs. In addition, I'll just give a shout out to Alex, who gave a talk on Monday, which also introduced a new feature, which is let's just not use CloudStack VR. Let's empower users with one more option, which is self-service shared network feature. So what that allows users to do is bring in their own routers, because now you have shared networks. Users can create L2 networks, and you can essentially bring in something like an F5 or a pfSense or a VYOS, essentially your own router. So this is just to kind of touch base on the traditional CloudStack upgrade process, right? What would happen traditionally is, and this is true from the beginning of the initial incubating release until at least 4.16 or 4.17, which is before an upgrade, you'll register the template for the version you want to upgrade. Once you upgrade, CloudStack will say, hey, have I found the new systemvm template? And it will update the internal database. It will ask in the release notes, or the users or admins will shut down, or they'll destroy old system VMs in virtual router. You'll have to contact your customers, get like a maintenance window to do all of this. And then once you are in that maintenance mode, you'll destroy, shut down those system VMs, virtual routers, SSVM, and CPVM. You'll start them, or CloudStack will start them, and CloudStack uses the rest of the patching process, which is using systemvm.iso and starting the services. So the downtime essentially is in the process when you kill your old system VMs and they're getting replaced by the new one. Now we thought, how can we solve that? So this is from last year's talk, where we thought about there are some core services and there are non-core services. What do I mean by that is there are CloudStack VR features, things like firewall, port forwarding, general routing, and NATing. All those things are provided by the Linux kernel, which is the sort of kernel we use in the virtual router. The virtual router system template is based on Debian. So those are the things that always run as long as your VM is running, as long as the kernel doesn't panic, has an issue, or it doesn't reboot. So your core services and core features will always run. The non-core services are the one which aren't, let's say, causing that much of a downtime. These are services that kick in or are used either intermittently or maybe when the VM starts. Something like DNS and DHCP config, a password server, and if you are using something like load balancer and so on and so forth. A VPN, there are some star because it depends how you configured VPN. Does it reconnect? Does it auto-connect? Does having VPN, which currently is provided by strong swan, if it goes down, does that affect your SLAs? So we've introduced live patching as a feature, 3 admin APIs, and of course 2 APIs that normal users can also use, I think. So patch system VM can be used for system VMs, they're your SSVM and CPVM, and then for the normal networks, we've just introduced new parameters called live patch. So you can restart network or restart VPC passing the live patch, and it will simply upgrade your software, the software in the existing VR. It will not restart the VR. And this happens by this live patching mechanism, which kicks in the same logic that kicks in when you start the system VM for the first time. So we HCP the payload, the agent.zip for SSVM and CPVM, and the cloud script starball for virtual routers. Just to give a brief idea of what the patching process actually does, it kicks in this script called patch systemvms.sh. It makes a backup of existing software, and then it will apply the new payload, and it will do some couple of checks and try to restart some services. If they fail, they'll revert back to the previous software. So in summary, this is what the new workflow looks like. When you upgrade CloudStack, you simply do an apt-get update, or you do a DNF or YUM update. You don't register, or you don't even think about what do I need to do prior to an upgrade. Of course, it is still recommended that you read the release notes and upgrade notes. So when CloudStack upgrades, the management server restarts, you have a new code, new version, everything that kind of starts. It will detect whether there's a new systemvm template, because between versions, including minor versions of the LTS release, you may or may not have a new systemvm template. So if there's no systemvm template, it's nothing that CloudStack needs to do. You can still live patch. It's a good feature. Let's say you're on CloudStack 4.17.0 and you're upgrading to CloudStack 4.17.1.0. You can use live patch because it's essentially the same template and you just want to upgrade the software. In case there is a new template, let's say you upgrade from 4.15 to 4.17 and there's a new template, CloudStack will automatically detect that and register the template. Even in complex scenarios where you have multiple zones, multiple secondary storages, the automated lifecycle will take care of all of that. And then again, users have an option, admins have an option. They can follow the traditional path, which is stop the system VMs, destroy the old system VMs, and CloudStack will do its job and it will create new ones. Or admins can decide to live patch the system VMs. And yeah, there's some limitations, of course. So for example, I mentioned we are restarting some services. If those services prove to be causing some kind of downtime, then yes, you will have to have a maintenance window. However, restarting an entire OS and restarting a service. I mean, restarting a service is usually very fast, can take a couple of milliseconds, and your service is up. For example, when you live patch an SSVM, these are the services. The cloud service, which is the agent, the Apache web server, port map, I think, for NFS, those things get restarted. For CPVM, it's just the agent service. For VRs, it depends on the kind of network you're on, but generally, you'll typically expect your DHCP DNS server, your Apache web server, and HA proxy if you're using load balancer to be restarted. Now, there are some limitations where a template upgrade is unavoidable. For example, there's a kernel security issue in the first place. So you want to apply a security patch, but that requires the kernel to reboot or restart. In those cases, you have to destroy your system VMs. You can't simply use live patch. Or if there are fundamental changes in the package dependencies, like there's a new JRE, for example, or there are maybe fundamental changes in the patching process, so that can also require this. This is an example which we hope to document and update in the release notes and the documentation, which is when can somebody consider live patching. So in this example, if somebody is using CloudStack 4.13 and before, they can't use live patching because it used an older version of base operating system. So all those things are old, it will not work. You can't use live patching. If you're using 4.15, there's caveat on a particular package, but you can use live patch. And certainly if you're using 4.15, so between 4.15 and 4.17, we found there's practically no difference or functional difference, of course, so you can live patch and it just works. Now, why does live patch work in the first place? Because there's one thing which is common since 4.0 and 4.17, which is SSH mechanism always has worked. The mechanism for management server or the route to proxy to SSH into system VMs has remained the same over the years. And that's what we consider as sort of the backbone for implementing this feature. So that's it. Demo time. I hope the demo cards are with me. And if not, I might ask the audience online and in the room to refer back to Nicholas's talk on Monday, where he sort of has given a demo. So I'll try to spice it up, and we'll do everything from scratch, because I suppose we have some time to kill also. All right, so I've got a system, a remote system, where I think we can exit this. Yeah, I've got a remote system, a CloudStack 4.15 environment. And we'll do two things. We'll first upgrade it from 4.15 to 4.17 and see, does the promise of an apt-get update or a DNF update actually work? And the second thing we'll try is live patch. So in this environment, what I've done is I've created two VMs, a VPC network and one isolated network VM, and we just want to see if they are working. So if I scroll down, you can see CloudStack 4.15.2.0. So we are on 4.15. Let's just reconfirm that. So we go to the infrastructure tab, and we see there are system VMs running here. If I open the console, then shortly we'll see the systemvm template version, if it works. Right, so we see the systemvm template version is 4.15.1, and we see a console, so we know it's a systemvm running there. If I scroll down maybe to virtual routers, you can see the different virtual routers. We see the version, and it's the same story, right? I can open the console, and it will show me the virtual router version, which again is 4.15.1. I've created a network. It's an isolated network with the egress rules allowed. So like you can sort of ping in, you can download stuff. And I've created an SNAT on this particular IP to a guest VM. Of course, I've punched in firewall rules for port 22. So this is my VM. And what I can do is maybe SSH into this VM. So this is 172.20.100. That's the SNAT VM. And I can put in my password. All right, so this is the VM, and if I say IPA, you can see it's 10.1.1.2.0.9. So let's just quickly check the NIC. Yep, 10.1.1.2.0.9. So here I can maybe start pinging Google, because when your routers are down, guess what we do? We ping Google. Let me SSH to the VM again. So I'm using tmux, split the screen. So at the top, you got your ping, google.com or 888 or, oh wait, I said Google, but I'm not using Google. So, right, at the bottom, I've got the system VM, the guest VM access again. And what I'll do is I'll just download a large file, right? Because this is when you challenge demo gods, right? Ping, everyone can do pings, right? You miss a ping, nobody notices. You download a real file, right? And then you know whether the system actually works. So we'll do wget that, but we'll not run it now, right? We'll first upgrade CloudStack, because when you upgrade CloudStack, your VMs are still running, right? When we do live patching, just before that, we'll try to download this file and see if it actually works. What is this test environment, right? So this is running on a single box. It's like a virtualized environment. So using MBX list, and you can see it's got one management server, 2 hosts. So if we again go back here, you can go to infrastructure, summary. You can see there are 2 KVM hosts. So we are trying to expand the scope of demo. So we'll not just have to upgrade CloudStack management server, but also the KVM. Can we do it in the next 15 minutes? Let's find out. All right, so what I'm going to do is I'll SSH, and this is kind of a utility you get with MBX. So you can SSH into the management server host. Yep, and I've got another environment where I can SSH into the KVM hosts also, because pick something realistic like KVM, not VMware, where you just only need to upgrade the management server. So we are on KVM host 2. Yep. All right, so KVM host 1, KVM host 2, the management server. We start our upgrade, which is simply updating the yum repository. So what I've done is, in order to make the upgrade sort of run faster, I've got the packages mirror running somewhere. So I'll just show you so you don't feel like I'm kind of masquerading things. So I've got this thing. So I'm hosting a mirror. This is, by the way, my side project, because I worry what will happen if Windows Server goes down. So we'll replace it with 417. Yep. And let me start the upgrade here so you can see. So maybe I like tmux, and what I can do is I can tail. Actually, I don't need to tail really, right? So I can stop the management server. Right, so CloudStack is stopped now. And now I can do yum install CloudStack management. So it will scan something, I hope. While it does this, let me just go and update the yum config on other servers, because you multitask when you upgrade, when you're confident about upgrades, of course. So I'm going to change it to 417, and I'll just say yum install CloudStack agent. Yep. And I'll do the same on the third server. Right, let's see, there's some activity here. So here it seems to be upgrading from 415.20, we see here, right, 415.20 to 417.10. So I'll say yes, of course. And to this also we say yes. And to this, I think it's still loading up the cache. Yep, yes. While this is doing that, I'll just try to show you around the management server. So we go to user share CloudStack management. Oops, I can't type. You can see a bunch of folders here. This is 415.20. As we install 417.10, I'm expecting that we will see a templates directory. That's where we're bundling the systemvm templates. So let's see if that process is taking time, or is it done? Yeah. Okay, so agent is done. So maybe I can restart agent. Systemctl restart CloudStack agent. Yep, okay. By the way, I like this feature now. When we install CloudStack, it will print this thanking the user and giving some pointers like where you can reach out the community. So yeah, feel free not to ignore this. And when you have a bug, you can join the mailing list and of course, and reach out to us. So KVM host 1 and 2 are upgraded, and management server is still taking time. I can do a verse list just to see what's running where. So you got host 1 where you're running the routers and this, and host 2, what are we running here? Yeah, okay. All right, your management server is up. And I'll just double check that management server is not, this is use it server, which I think I forgot to upgrade. I'll just shut it down. And yeah, actually we don't need use it server at all. So I'll just start. Before I start, let me show the directory structure of the upgraded management server. Sorry, I can't type, looks like. Yeah, so now we see there are some new folders here, right? We got templates, which are systemvm, and of course the other directories are there. So if you go to templates, and we go to systemvm, so these are the systemvm templates that were sort of bundled in the CloudStack management server. So all I did was yum install or yum update the package, and it upgraded CloudStack, and I've got the systemvm templates sort of bundled in. Now what I'm going to do is, I'll just tail the management server logs, which are, yeah, they are not running. And I'll start the CloudStack management server. And then we'll tail the logs, of course. So we see it started. It's searching the module hierarchy, yep. And then it's applying, it's checking the database update, a version, which is 4.15.2.0. It's checking the code version, which is a newer one. So it kicks in the upgrade path from 4.15.2.0 to 4.16, well, 4.16 to 4.17.1.0. See a whole bunch of SQL files, nothing out of the ordinary. Once the database upgrade path has gone through, we see something interesting where CloudStack tries to see, is there any systemvm templates I need to look for? And we see here, it says updating systemvm's IDs. So it's scanning, Hyper-V not found, OVM, LXC, VMwares, and so on not found. Updating KVM, okay, looks like we have a KVM environment. So it checks for all the zones in the environment managed by this management server, which has distinct hypervisors. So all the distinct hypervisors, it will automatically upgrade. And it does what you would expect it to do, right? It will mount the secondary storage, and it will scan the template, it will copy the template. It will run a script which will set up this template. And this is relatively quick now and automated. So now it says successfully installed the systemvm template, right? Notice it installed in this path 1/202. So people who are aware what these folders and number mean, this is your account ID and the template ID in the database. So, and it's unmounting your store, right? So that means CloudStack is upgraded. Wow. I mean, we didn't have to do all of this. Now, what does that mean for the UI? So if I refresh the UI, I should expect to see 4.17.1.0. And that's, ladies and gentlemen, the flawless upgrade using simply apt-get update or upgrade. So you can see CloudStack 4.17.1.0. Everything seems to be running, right? I mean, VMs are running, and if we go down here, system VMs, they're running and they're up. They're connected. What's happening? You're using 4.15.2.0 system VMs connecting to 4.18. It's because we do support the command answer pattern. The sort of protocol level compatibility has been there for so long, so it simply continues to work. And I think I know there's an issue, so I need to maybe reopen the VM, the UI. Again, note to the CloudStack dev community that when you upgrade, sometimes the UI elements are cached, so you need to, we need to fix that. Awesome. So systemvm template lifecycle automated, done, tested. Now comes the live patching bit. So if you go to systemvm, I can hover around and I can see these quick views, right? One of the features, patch systemvm. I can use it through the quick view. I can go to the system VM view and click on this patch system VM also. Now what we'll do is we'll just do it for the for the CPM first. But it doesn't matter what you do next. So I can click on patch system VM. Just please confirm you want to patch. Yes, okay. And we'll just tail the logs to see what's happening there. So what it will do is it will use SSH and HCP to copy the payload. And if there's an error, right, we'll see an error. Didn't happen to me yesterday, so it might happen today, who knows? Fingers crossed. So we see it sent some payload, and yeah, we got an answer, status update here, and it will then restart the agent. And when the agent restarts, we'll get this sort of connection, right? There's some address trying to connect, and this is the thing. And the certificate says v2 VM, right? So it's like patching has worked. It says patch system VM. Excellent. If I refresh, I should see the console agent up and running. So I've upgraded from 415.20 to 417.10 without, let's say, the downtime or let's say a longer downtime of your CPVM. So now if I click this, open the console, you can actually open any VM console, right? I would expect my CPVM console to just work. While this is happening, I'll just show you very quickly. When you go to system VM, in here you can see the agent version, right? So we still see the SSVM agent is 415.20. But now if you go to the CPVM, which we have patched, now the agent version has upgraded, right? Which means your software has just upgraded. So awesome. Let me just shout out to Pearl De Silva, who developed this feature. It's not here joining me the stage, which is such a shame for us, but yeah, just to shout out to Pearl, who've kind of implemented this feature. And we can do the same for SSVM, right? Just to show you, we are on 415.20. Now maybe let's use the quick view option. So I can force, I can simply click OK. I would just expect it to work because you do it a couple of times and you develop mechanical sympathy to systems. And then you know when something works, you just kick these things at scale and you know it will just work. So virtual routers. You got the virtual routers. So our guest VMs, you know, from before we started the upgrade, is on 415.10 based virtual router, right? And we can see it says template version 415.1. It says software version NA because we just introduced the live patch mechanism in 417. So oldest virtual routers don't have a specific file that says, okay, this is my software version. That's why you see NA. Going back to a guest VM, right? Your ping is still working. Let me just go to the other console, do like a control C, 0% packet loss. That's good. That's good. We've done live patching of system VMs and guest VMs. Well, of course, you would expect it to not cause any problems. Now what we'll do is we'll live patch the router, right? So that's where the manually test comes into picture. We'll download this file from download.cloudstack.org. It's probably going to take 5-10 minutes. Let's hope it patches in 5 minutes. So I can, sorry, where's this? Here I can patch. And it does the same, right? Let's just watch. So this thing is going on. And here I should see some activity, the same kind of activities I would expect with SSVM CPVM. Right. It's doing some activities. Your download seems to be working, ping seems to be working. And it's patched, right? I've patched my virtual router, upgraded from 415.20 to 417.10. My ping is working. And where's Nicholas? Take it, Nicholas. My wget is working also. That's how you do a demo. If you want, I can keep it on the side so that I can talk about it. Let's go and maybe upgrade your VPC router also. Like you can click on patch VPC router, and you would expect it to just work because #CloudStack just works. Right, so this thing will go on. I mean, we can spend 3 minutes staring at the screen, but I'm sure we all can agree we can move along. So that's pretty much it. Your router sort of works. Now, let me also touch base on a feature we introduced a couple of versions ago, which is rolling restart. You know, the limitation I talked about, sometimes you have a new base OS, you have a security fix. What do we do in those cases? Well, there's a way. It's not elegant, like live patch, but there's a way where you can restart network with cleanup. But now what this thing will do is, and of course you will have some kind of downtime. Actually, let me close this one, but I'll keep the ping open so you see the point I'm trying to make here. There'll be a downtime, but it will be the minimal downtime we can hope for. So what this thing will do is, I say cleanup OK, and it will actually deploy a new router. So the previous mechanism before rolling restart was destroy the old one, you create a new one. However, there are so many steps that happen when you destroy the old one and create a new one. So we thought, let's just create a new router first, and then we'll destroy the old one, and we'll do like a gratuitous ARP ping. So like your switches and devices, everything sort of they get updated. So it is deploying a new router. You can see, right? Template version 4.15.1 and router software version is 4.17.10. And we got the new one deployed, right? Template version 4.17.0 and software version 4.17.10. And the old one is destroyed and gone, right? So there'll be some ping packet losses, but they'll not be huge, right? In the best case scenario, if you're using redundant virtual routers, the ping loss will be like a second, because in case of a redundant virtual router, as soon as you destroy the backup one, new one is deployed. So it will switch very fast. So you can plan your upgrade in a way where you can sort of get best of all the options you can do. So here we see, right, template version 4.17.10, software version 4.17.10. If I open the console, you can see the router version, right? It says systemvm 4.17.0. So that's the template version, and software version is of course new. All right, that's the demo. Thank you, demo gods. So what's the future? Well, there'll be an episode 4. Sorry, 5, because this is the 4th one, right? Where we are hoping for a new VR agent, which will further streamline this. In the last talk, in last couple of years, we experimented with a whole lot of things. How can we have zero downtime upgrade of even the system level patches? Because if you think about the VR, it's a Linux box, this sort of tiny small box with only 120 gigs of RAM. So we thought about things like, can we do containers? Can we do a whole lot of things? But you don't want to suddenly in your release note say that, hey, now routers will consume half a gig of memory. We don't want that. So under these constraints, we're figuring out what more can we do for our users. So we're thinking of standardizing how we configure things, maybe use cloud in it. Thinking of a smaller system template, where maybe the software, instead of a patch, we think of maybe a container image which can like replace one version of the software with another. So we're experimenting with those ideas. We now have Podman, which you can use with systemd. So you can configure to run a service like HA proxy or Keep Alive D or the DHCP and DNS services or the Apache web server to run inside containers. And of course, the VR agent, which can orchestrate and further simplify how we communicate, how do we upgrade, and how do we talk to CloudStack VR. So maybe there's a episode 5. Shoot, if you have any questions.
Okay, I think your demo was too slick, was too efficient. You've got plenty of time left, unfortunately.
Just like CloudStack, right?
We were anticipating some failures. Okay, are there any questions from the room for Rohit? There's David, thank you.
Yeah, Rohit, thanks for the cool demo. So I got a question. So previously, if you'd want to tweak your system VM, you could tweak the ISO, and then whatever changes you had would persist despite reboots or destruction. Is there any feature to do that with live patching?
Yes, you can. I mean, here's a side effect of this feature. As a developer, when you're developing features, making fixes for the VR, you would either SSH into the VR, and like on the VR, you'll make changes to your script and then do your testing. And once you're satisfied, you'll copy the files back to your, let's say, source directory. Now with live patch, all you need to do is make changes to the files in your IDE, have like a helper script, which we can, to create the starball and kick in the live patch API, which will like reconfigure the software in the VR on the fly. you need to copy it to a class path where the management server can find. Now, where are those things on the management server, right? That's probably the question. So it's actually in the user share, if I'm not mistaken. The ISO used to be in the the CloudStack common package. So it's in the common package, but instead of the ISOs, so this ISO is like a backup, right, from 4.15.2. We now have these scripts. So all you need to do, let's say there's a security bug that comes in, and we can say, okay, go and apply changes. Or as a developer, go and make changes, create a tarball, upload it at this path, kick in the live patch API.
Okay, thank you. Bobby.
Thank you, Rohit. It's a very, very lovely presentation and demo. One thing I noticed, and I don't know, is when you live patched the CPVM, there was an option to force. What are you actually forcing with that?
I think I'll have to check the API documentation.
Maybe,
but I think if there's a failure in upgrade, I think it goes through that. So like you're kind of forcing something, because the script, I think it checks whether there's an error, and I think force will like override that.
I thought about it, and I thought it was it checks if the software version is the same. It
Yeah,
wouldn't
I think
copy,
that could be.
and
right.
force would simply override.
Yes, yes.
I thought about it.
No, I think that's what you are absolutely right. I missed that. So the way live patch works is it checks, okay, which version or what's the checksum of the cloud scripts in the VR, and what do I have in the management server. It will say that, oh, I've got the same version, so I don't need to live patch, because you don't want to do this. It's heavy on the management server. If you have 10,000 virtual routers, you don't want to have that. So live patch is it compares the payload it got, the sort of, let's say, some kind of SHA or checksum for that payload. If it is the same in the VR or SSVM, there's no point to repatch that. I think force will still force to patch that.
Thank you.
Okay, Wei, thank you. By the way, Rohit, there's a comment online. Very good talk and great demo.
Thank you, absolutely. As I mentioned, such a privilege to see people.
Thanks, Rohit. Great job. My question is, so how to ensure that the new configuration and new script work with the old system and template, which has an old Debian version, old software version?
So I think, as I said, we can't cover all cases. So we have strictly said 4.13 and before, we don't think it will work with a level of confidence. So in our testing, we said 4.13 and before are very old release. So we are thinking 4.14 onwards, you can use it. 4.15 onwards, we definitely can use it because there's a whole lot of testing that has gone through. Our demo was from 4.15 to 4.17.
Thank you, Rohit. Any more questions for Rohit from the room? Okay, great. Please, hands over Rohit. Thank you, Rohit.
Thank you. Thank you.